This is the Behringer 150 module from the System 100 series, and it's a multi-purpose tool which shouldn't be missing in your System 100 collection. It features an LFO, which is the same we already had in the 140 module, a ring modulator, a sample and hold circuit, and a white and pink noise generator. The LFO is an exact copy of the 140 LFO. It also features 5 waveforms, a normal and an inverted output, an output range selector, the trigger and frequency CV inputs, and the manual frequency and LFO delay faders. For more details, just follow the link in the top right corner now to my review of the 140 module. This ring modulator here is an audio tool, and it cannot handle constant voltages since it is AC coupled, and it will pull any constant voltage back to zero quite quickly. The general principle of ring modulation is to multiply two signals, X and Y, and the output is the resulting product. With audio rate signals, this typically leads to the well-known metallic and very rough sounds. This ring modulator here is normal to the white noise and the LFO output, and this gives us basically an intermittent white noise as the amplitude is now modulated by the LFO. The LFO currently outputs a sine wave to this ring modulator, and interesting here is that we hear the white noise during the positive half wave and during the negative half wave, because the inverted white noise sounds the same as the non-inverted one, and actually this holds for any other audio signal as well. When we switch to the square wave here, the sound doesn't really fit to what we would expect, and we would expect an on-off white noise sound because the square wave of this LFO oscillates between 0 and 5 volt, and if we multiply this white noise by 0 it will be off, and if we multiply it by 5 volt it will be audible. The current behavior here originates in the AC coupling of this ring mod, which we can basically interpret as an internal offset that compensates any constant part of the input signals. So we can hear this white noise every time the LFO switches to its 5 volt output and every time the LFO then falls back to 0. We can visualize this with a constant CV at the second input, and the output now is not a square wave, but something close to a short decay envelope, which falls to 0 as the internal offset quickly compensates the DC content in the input. By the way, this whole offset compensation works fully analog and is achieved by simply adding a capacitor in series with the input signals. We can see this here and here in the schematics, and downstream of these capacitors, the DC content of the input signals is already compensated. And then this big block here is the actual multiplication IC. If you're interested in more details about ring modulators and the harmonics that they can generate, just check out my ARP 2500 mod amp review. The link again is in the top right corner now. This is the sample and hold circuit, which briefly explained stores or samples a voltage, either a CV or an audio signal, that doesn't matter here, and it provides this sampled voltage at its output until we sample a new one. The sampling speed is governed by an internal clock or by an external clock which has its input here. And with the external clock, the fader has no more effect, so it doesn't become an attenuator or anything like that. You can see the clock speed by this green LED here, and the clock signal, either the internal one or the external one, is also available as an output here, which is very handy if you want to synchronize other things to this sample and hold. And you can also just route your clock signal through this sample and hold, grab it here and use it for further stuff. without wasting a multiple. The internal clock has quite a limited speed range and doesn't go into the audio rate. However, if you use an external clock, you can go as high as you want in your frequency, and this sample and hold follows an oscillator up to its highest frequency. So you can sample and hold in the audio range, which leads to some interesting results. If you sample an oscillator, for example, using a second oscillator which provides the clock for this sample and hold. Here we have the output from this sample and hold, and this fader here applies a lag to the output, which means a smoothing effect, like a portamento. Finally, here we have the input to the sample and hold, which is selectable by this switch, and it can either be an external signal, the current LFO output, or white noise. Sample and hold circuits work with capacitors that basically store the sampled voltage, but these capacitors lose their voltage over time, so it's typical that there is a voltage drop in the sample and hold output if we don't sample for a longer period. For this sample and hold here, the voltage drop is quite significant, so we can hear and see this in this setup now. The sample and hold now goes to the pitch CV of an oscillator, and the sample and hold input is connected to a constant about 2.5 volts. We can now clearly hear that the pitch of this oscillator decreases as the voltage of the sample and hold drops. Another sampling now sets it back to the initial pitch. This sample and hold here has a much faster voltage drop than its ARP 2500 counterpart, which is very stable compared to this one here. Well, I already covered sample and hold circuits in my video about the ARP 2500 sample and hold, so if you want more background info, just follow the link again in the top right corner. Well, last but not least, we have the noise generators here, which provide us with white and pink noise, each of them with two outputs, a sound that contains all frequencies. So when we look at the frequency spectrum, it's basically a plateau. See a square wave here for comparison, where you can clearly spot the fundamental frequency and its harmonics, but not so in the white noise. Pink noise, in contrast, is a bit darker sounding and has a decreasing amplitude in the higher frequencies, as we can spot here in the spectrum scope. These noise generators are handy either to drive the sample and hold, for example, but also to synthesize hi-hats or any other percussive elements. That's it about the 150 module, which is an important piece of the System 100 series. Not only that it gives you a second LFO, which is always good, it also gives you the ring modulator and the sample and hold circuit, as well as the white and pink noise generators. And all of these are important components for a classic subtractive synthesizer. At this point, thanks for watching and stay tuned.